Hi, I'm Brandon Campos, the Operations Officer of Trispec. Today we will look at an overview of the phase array process and efficiency in the field. But first, let's take a look at the equipment we will use and how it is set up and calibrated prior to weld inspection.
The first step we take in any phased array scan we perform is choosing our wedge and probe combination based on the material type, thickness, and size we'll be scanning. Different probes provide various frequencies and power, while the assortment of wedges allow for adhesion to various curvatures of different material. For instance, here we have two different size and curvature wedges, along with two different frequency and size probes. Now, once we've chosen the proper combination of probe and wedge, we adhere them together with ultrasonic coupling. What this does is it eliminates any air gap in between the surface of the probe and the wedge, allowing for sound to pass through without issue. Once that's completed, we move on to the calibration. Now, this is a NavShips calibration block that has side-drilled holes at different depths across the face, used for distance amplitude correction and sensitivity. This ensures that the sound being transmitted into the material is returning to the probe at the correct timing. Once that calibration is done, we move on to the material-specific calibration. Now, these blocks are built to cover a wide variety of material, thickness, and diameter. They're built to be code compliant with precision, EDM notches on the ID and the OD of material. These notches allow us to hook up our probe and wedge combination to verify that we can locate and size each ID and OD notch. Once that's completed, we're ready to go. Now, some jobs might have multiple scopes of work with different material on them. When this occurs, we do swap out the wedge and probe combination and then recalibrate after we recouple with the NavShips and whatever new material that we're going to be scanning. Once the calibration is complete, we can then load up the scan plan on the machine. This plan is like a blueprint built specifically for the material at hand. This tells the computer how to properly collect and review the data as we scan it real time in the field.
Our first example follows Jesse Mansfield performing PAUT on a 10-inch diameter, quarter-inch wall pipeline at both tie-in and mainline stages. Here is a close-up of a dual probe setup, allowing us to complete a single offset scan on each side of the weld with just one pass on a tie-in weld. Here is an overview of that scan being performed with intrinsically safe equipment and only tap water as couplant. No chemicals needed. Next are a few mainline welds. Here you can see the data being reviewed in real time during the scan. Scanning the same size and thickness allows us to simply detach the scanner and walk over to the next available weld without interfering with other workers. A quick overview highlights the safety that accompanies phased array: no generators, no chemicals, no radiation sources, and no heavy machinery needed to complete these inspections. Lastly, we will look at the implementation of phased array on small bore piping in higher trafficked areas. Jose Tapia is scanning multiple 3-inch Schedule 160 welds. Notice how there isn't a need to close off areas or stop all work due to radiation concerns, because phased array utilizes the safest technology available for volumetric inspections. The same technology used by doctors performing ultrasounds on babies in the womb. A close-up of the small bore scanning alongside the machine gives you an intimate look at the live data capture occurring during scanning. We can not only track our results in real time, but can also verify data isn't being missed. Once the reports are built from the data collected, they can be stored and shared digitally at the press of a button.
Hi, I'm Scott Summerfield, Managing Partner at Trispec LLC. Phased array ultrasonic is fully code compliant across all major standards and has been widely accepted in the petroleum, power, nuclear, and aerospace industry. With offices across the United States, Trispec can efficiently service multiple regions. The technology is not constrained by environmental or regulatory concerns and can be easily deployed due to its non-hazardous nature and compact size. At Trispec, we strive to be on the leading edge of industrial ultrasound technology. We deploy multiple inspection systems and methods to perform new construction and in-service inspections. The three-dimensional view made possible with phased array ultrasonic provides for better detection of critical through-wall discontinuities when compared to the limited views provided by a radiograph. While adhering to our motto, built on integrity and driven by quality, we strive to deploy advanced ultrasonic methods to our customers, providing increased quality of inspection, faster production times, and a transparent, easy-to-understand process from planning to completion. Thank you for your time and attention.